So um, instead of just building this into the API, which is a pretty simple process, we are going to make it into a reusable plugin. And I think this really demonstrates the power of DTQL here. So we're going to go, if you look at the API structure, we have within the vendor folder in Expressive, we have a set of libraries. We're also going to install our plugins here. So I'm going to go to API vendor Expressive, and I'm going to say, yo, Expressive app API plugin. And what this is going to do is similar to the original generator. It's going to ask me a question about what I want to call this plugin. We're going to call this one winery. It's going to create this folder here. Now it's actually going to write in, fill in a bunch of code for us. So we're just going to let it overwrite all the template files. And when we're done, everything should be configured to connect to a remote repository with the right plugin names. All the models are linked up. All the namespaces are done, everything. There's some sample models and providers in here. So if you want to know what you're actually aiming for, we can, this is all configured. It's already got the namespace of winery. So I can copy and paste this file to create code, which we're going to do later. Plugins have their own migrations folder. And this is really key to the whole process. The plugin is able to manage at least a portion of the schema in the database. And so we start out with this migrations folder. It has a 1.0.0 DTQL file. And if I create a 1.0.1 DTQL file, make changes to the schema, anybody who has a copy of this plugin that's at version 1.0.0 and then runs the update will get the new schema changes. So if I add a column or I change a column, whatever, that's going to happen automatically. So that allows us to maintain a winery schema across any number of projects. We also have the source directory, which has models and providers. These are only necessary when you need to customize data, but getting the meta to automatically generate things is sort of beyond this tutorial, so we won't cover that. We're just going to build a model, keep it simple. We also have unit tests, so basically any custom code that you write that's not generated by DT, which is very little, you should test through a unit test to make sure that it's all running. This is all set up so that if you run a unit test, you'll know right away whether the latest plugin is breaking anything. Okay. And then we have a data folder. And this is actually what we like to do with our plugins is provide a set of content up front. So in this example, we would probably set up a couple of realistic wineries, maybe Blake's Winery and Grant's Winery, that when someone uses our plugin in their app, they're actually pre-populated with data. So when you go into your own app, you'll actually see that pre-populated data, and it gives you something to start working from right away. And a lot of times for us, when I go to a client and I say, okay, tell me what you want to do, and they tell me a story, I write that into a use case. I give the characters names and whatever so we can remember them, and then basically we create that data set. Like, we tell the story of what should happen, and then we create the data set as if it has already happened, and then our app is actually finished before we even start. Okay, so let's take a closer look at the winery data, which I'm pretty sure I don't have on hand, so let me go get it.
So you use the scrape command to scrape all that?
No, we're going to use the scrape command to bring the data into our site. Okay. We could have scraped it from the web pages, but we didn't. Instead, what we did is we went and downloaded, like we clicked the link here on this. We basically downloaded this. Okay. I don't remember if they have a download link on this page, but I think we just copy and pasted this into Excel or something and then saved it as a CSV file. But when you're done, the data should look like this. We like to put our data inside of the data folder of the project. And one of the reasons for that is we don't put production data in our code repositories. So the data folder is not a repository. It's not going to get stored to source code. So we're safe to put big giant data sets in here and just keep a local copy and pass them around as needed. The winery's data, when you download it and save it as a CSV file, should come out looking like this. Okay. There aren't that many columns. It's a pretty simple structure, but you'll see that actually it introduces some complex schema issues. So there's basically a permit number. This is our unique identifier that we can use to guarantee that this is winery ALW15008. That comes along with an owner name. Sometimes they have an operating name, sometimes they don't. And we'll see how DT model can be useful as an accessor to sort of massage that away. We would want to have, like for Whippoorwill Vineyard, we'd want to use this name unless there is no name here in the operating name, and then we actually just default over to the owner name. So a DT model accessor makes that really easy to do. The rest of the columns in this file are actually just sort of street address. So we have the street, city, state, zip, and county of the wineries. So it turns out that we actually already have, and by the way, all of that is documented here. The winery data, this kind of gives you the overview of what's in here. Okay. It turns out that we already have a plugin for locations called API location. And so what we're going to do is we're actually going to bring that plugin in and hook it up to here so that we don't have to write any of the street address code. We can do mapping, all kinds of things automatically. So, and this is sort of the same process. This API location plugin is no different than the winery plugin we're building. They're built for reuse to do exactly this sort of thing. So what I'm going to do is I'm going to add a few lines of code to our API composer file to allow us to pull in that plugin. Because these are expressive code, they're actually on GitHub, GitLab. We have to go and tell it where the repositories are because they're not a public space that you can access. So we have to stick this line in here. And then we're going to add this because I don't want to go through how to actually do the repository. So I'm cheating a little bit, and I'm just going to, instead of pulling this from the repository, which is where it would eventually reside, the plugin, I'm just going to tell it to go into the folder and look for it there. Normally you would set it up just like we're doing for API location. So this is the composer file. I just stuck all the necessary pieces in place. At this point, I can now go to our API folder and run composer update. And it should install the API location library for us. It's also going to install a bunch of development environment stuff because I ran Composer without the no-dev flag, and it turns out we actually need the development environment to do the scraping part that we're going to do next. So it's good that it's going to go through and do this. At the end of all this, we should have an API location plugin, and this structure is actually identical to the winery structure that we're setting up because this plugin was built using the same process. We want to bring the data into our API, so we need to set up a table for it. But rather than running conventional SQL, which would be stuck in an SQLite or MySQL database, something like that, we're going to use DTQL's data independence and migration management feature to actually add this table in DTQL and manage it for us over time. And that's especially important if you're doing plugins, because who knows what database environment you're going to be in when you need to do a plugin. Within our project structure, we have in the API folder, there's a migrations folder. This is that make file that we looked at earlier, looks in here for the version updates for the app. We do the same thing in the vendor folder to find our winery migrations folder. So now we're in the migrations specific to this plugin. The template already comes with a 1.0 that's empty. So we're just going to paste in the code from the tutorial here. And what this is going to do is it's going to create a table called winery. This is the schema Vino. So it creates the table winery. It's going to have a primary identifier. It's going to copy that permit number over, which we call a TTB number, the owner name, the actual name of the winery, and then this location ID column is actually going to be a foreign key reference to the location, which comes from the API location plugin. So if we look at the migrations for this file, you can see that it actually creates a location table, which keeps track of all the street address information, everything that we need here. So effectively, these two plugins are going to be linked by this location ID. All right, so that's done running. So we actually, because we have these new plugins in place with the new migrations, we need to run make clean again to actually build in those structures. When we do that, it needs to be run from the project folder. So this time it caught two new, we're gonna ignore those for now because we're not using the meta. It brought in two new plugin schemas for us, API location and API winery, both are version 1.0. So now if we take a look at our data structure, we will see that it's actually brought in a winery table, which looks like what we expect. And it's brought in our locations. It also included a state table. Now this is pre-populated. Remember I talked about having that static data available to pre-populate things. So this actually builds out our state data table. So our locations then have a state ID that connects there. That's and cool. This is why that the CSV file is not just a totally straightforward pull in, because if you look at it, we actually have, where's my tutorial? There's actually sort of a complex structure. We have the winery, which has a location, which has a state, right? So that's at least 3 levels that we want to create records in different tables. So I'm going to show you how blueprints make that super easy.
So if I'm like working with a database admin and I'm the app, so I'm going to basically, from what I'm understanding, is I'm going to write my stories, my use case, and create what I need to from an app side, and then I go to the developer, to the DBA, and I can be like, hey, this is what I need.
So actually, the way that we approach the conflicts between developers and database guys is that both can create the pieces that they need, and they mesh together fairly well. So like we have our front-end guys and our back-end guys at the same time building their components. So we may have the front-end guys building out a plugin while the database guys building out the app structure, something like that. So because all the schema is modularized, people don't get in the way of each other very often. And because DTQL is fairly easy to read, there's nothing complicated about this. You can have anybody go through this and understand exactly what action is being taken. We're adding a table. We move a column. We remove an index. Whatever we want to have happen, it's basically self-documenting here. So you can see at every step for every version exactly which steps were taken. A column might get added, removed, whatever. It's up to the developer and the database guy to decide what that final structure looks like, but it's a cooperative effort. Okay. And that sounds a little crazy, but at the end, you just end up with these big piles of tables. And you say, well, sure, but we don't even use location type for wineries. But what's the harm in an empty table? That's not hurting anybody. So we sort of let the plugins do whatever they need. We may find down the road that we actually want to have wineries of different types, right? We might have wineries that have restaurants versus wineries that are open in the winter, things like that. We can actually classify our locations, and that functionality, when we decide we need it, is already built in.